So now we are with continuing with part 2 of the example 9.3. Just need to, before I said 25 times 250, sorry, it is 0.25 because 25 it is 25%. So it is 0.25, or otherwise we might say 25 times 250 over 100. That's it. 0.25 times 250 will be obtained 62.5 gram is the fat content inside the biscuits. Okay, so sorry for that mistake. Gonna continue now. As I said, from the maximum peroxide value, which is critical for the consumer, and we have the maximum peroxide value is equal to 15.6 milli equivalent of oxygen per kilogram. Okay, then this would be equal to 15.6 milli equivalent of oxygen per 1,000 gram. I'm obtaining it in a gram because the fat content is also in a gram. So therefore the maximum amount of oxygen, therefore the maximum amount of oxygen that would enter the pack, okay, I'm writing in details, and that would react with the fat inside, and that would react with the fat inside would be assumed by multiplying the maximum peroxide value, as I said before, times the weight of fat inside the pack. Okay, because all the oxygen it is assumed that would enter inside will react, as we said from the given, with the fat that is inside the baskets. So this would be the total oxygen that would be handleable inside the biscuits. The maximum peroxide value, it is 15.6 per 1,000 times the weight of fat inside. We have just calculated 62.5. Let's look on the calculator, and we will obtain 0.975 milli equivalents of oxygen. Okay, that's the first thing. We've got it over here. We're gonna continue. I have milli equivalents of oxygen. Milli equivalents of oxygen, this unit, I need to convert it to a unit that I might use it inside one of the equations that I have before, like delta W over delta T, okay? That is equal to the P over X, A delta P, or we said before Q over theta S equals P over X, A delta P, okay? These are the equations that we're gonna use at the end. But we need to convert milli equivalent of oxygen to another, as I said, SI unit that is handleable inside these equations. It is known actually that the value is expressed in millimoles of oxygen per kilogram equals half milli equivalents of oxygen per kilogram. Let me say it otherwise. Ouch. Just up with another pen. 1 milli equivalents, in other words, equals 0.5 millimole. Okay? Over here I have 0.975 milli equivalents of oxygen. How much millimoles it would be? X. X would be equal to 0.975 times 0.5. Okay? Therefore, يعني كأنه we are dividing it by 2, we will have a value of 0.4875 millimole. While I am obtaining air in millimole, the question, why I am obtaining air in millimole? This is because actually I need to convert it into milliliters. Because the maximum amount of oxygen that is permissible is actually Q. If I can convert it from millimoles into milliliter, I have obtained one of the factors over here, which is the Q, and this is very good. And I'm trying to obtain all the factors of this equation, okay, in order to obtain theta S at the end. I'm assuming I'm neglecting delta P, as I said, the driving force. I need to obtain Q, I need to obtain at the end theta S. If I can convert from millimole to milliliter, as we saw in the previous exercise in example 2, which is Q expressed in milliliter, then that would be perfect. Let's continue. Do you think in any equation where we can go from millimoles into milliliter? For me, yes. It is the ideal gas law equation. So we have the ideal gas law equation, which is V equals N or T over P. Okay? T is the temperature in Kelvin. P, atmospheric pressure, which is assumed to be 1 atmosphere. R, ideal gas law, the ideal R fraction, which is 82.06 milliliter atmosphere per mole Kelvin. Okay? And number of moles. And V, the volume in milliliter. Voila. So from this equation, we can get L, the volume in milliliter. I'm gonna write it down. And I have it over here, 0.4875 times R, the value also that is known, 82.06. Okay? Times T, I'm saying that the temperature is in Kelvin, and we have the temperature 23 degrees Celsius. To convert it to Kelvin, I have to add 270, I'm writing here. I have to add 273. So the value in Kelvin would be 296 Kelvin times 296 over the atmospheric pressure, which is 1. And the final value would be, just let me check the calculator over here, 11.8 milliliter. So 11.8 milliliter would correspond to the maximum permissible amount of oxygen through the package of both oriented polypropylene layer and through the nylon and LDPE. Okay, this is the Q because احنا here we are speaking about the conditions of the biscuits inside in case of any package. Now, how can we go into more details? We can go into more details specifically of each type of package with a differentiation in the thickness, and with a differentiation in the permeability, with a differentiation in the surface area, if any, but both also have the same surface area. And we're gonna see in the differentiation of the oxygen transmission rate. Okay? Now, let's continue. We have over here, now we can go into more details. We've obtained the Q, okay? We're gonna go into more details. A, oxygen transmission rate of the first case A of oriented polypropylene co-extruded 2 layers. I'm gonna write also the case over here. Okay. it is equal to 650 milliliter per meter square per day. And I have the X equals 25 micrometer for both layers. That's one. Now, the oxygen transmission rate, okay, it is 650 milliliter per meter square per day. So what if we have نحن the surface area, I'm sorry if you're not seeing, surface area that is equal 0.044 meter square. 0.044 meter square. Over here, the oxygen transmission rate per this respective surface area would be equal to 650 times 0.04. Okay, and the value would be 28.6 milliliter oxygen will be permeated per day per this surface area. So over here I have the permeance of oxygen per surface area. Please follow up because we're gonna see what this could substitute from the previous equation that we wrote, اللي هي Q over theta S equals P over X, okay, A. احنا عنا we assume that delta P is 1 and the driving force. This is the permeance per surface area. So as if we have both these factors. Permeance per surface area صارت معنا 28.6 milliliter. Q we have it before 11.8 milliliter, right? Let me check, yes. So 11.8 milliliter equals 28.6 milliliter over X. X, the thickness, 25 micrometer. I'm gonna convert it into millimeter, and we have milliliter, milliliter, millimeter, and it times 10 to the power minus 3 times theta. Implies from here I can get up the shelf life, which would be using the calculator. I need to make sure